We're team 1134, and we're doing a student problem, and we're trying to overview community relations in Sudanese refugee camps. So as you know, the Sudanese Civil War was a big crisis where Sudan and South Sudan fought over a big conflict, and South Sudan split off as a separate country. This created a large amount of refugees, many of whom went to different countries, such as Ethiopia, the Democratic Republic of Congo, and Uganda. In those countries, these refugees formed refugee camps, which were headed by the United Nations. And in these refugee camps, what happened is many different populations came together and interacted with each other. As we can see, there are many refugees, both from Sudan and from Sudan in refugee camps. In particular, we focus on refugee camps within Uganda, and we focus on the idea of how do these diverse populations with different ethnicities, different languages, everything, how do they interact, and like can we model them in a certain way?
We aim to model refugee interaction with each other. When different groups move in, they will have different conflict resolution models, and through these interactions, they will diffuse and share these conflict resolution models. The three conflict resolution models we aim to look at are negotiation, arbitration, and mediation. Our model will use two interconnected models. One, modeling interaction between populations, and the second, conflict resolution diffusion. Conflict resolution diffusion is dependent on interaction. As interaction increases, the chances of conflict resolution increase. Firstly, I will be going over how do populations interact over time. Some assumptions. Once interaction starts, groups do not stop interacting. Even if an interaction is hostile, a hostile interaction is still an interaction and will continue. The second assumption is that groups are in close enough proximity to interact. Refugee camps can be quite large, but in this case, we will assume that geography is of no concern. Our third assumption is that interaction will increase. As refugees spend more time in their camps, they will become more comfortable with each other and their respective groups, which leads to greater interaction. Thus, our interaction model is a logistic model. The logistic model has an upper limit that is denoted by AP, A being the proportion of people willing and receptive to interaction with other groups, and P being 100% of the population. The interaction model, the logistic curve, will never reach 100% interaction. And that is because there's bound to be some people who are not willing to interact. K is our constant defining rate of interaction. That is how quickly people start to interact with each other. As we can see, interaction depends on two main factors. A, percentage of people willing to interact, which becomes the upper limiting factor. K, the constant rate of interaction, which shows how quickly the logistic graph grows, or how quickly people start interacting. This in turn influences how quickly cultural diffusion of these negotiation approaches happen. Here's an example model. Here, the number of people, proportion of people willing to interact is rather high, 90%. A is 0.9. However, the rate of growth is 0.05, and it grows more slowly compared to model 2, in which K is 0.2. This means a faster growth. However, in this model, only 75% of people are willing to interact at the end. This means that our final upper limit is lower than before, although the model grows quicker. To summarize, interaction between groups increase as people become more familiar, and interaction is capped by both population and the percentage of the population that's willing to interact with other groups. This becomes important later on, as interaction and cultural diffusion of negotiation ideas is dependent upon each other. Specifically, the fusion of ideas is dependent on interaction.
Now we'll be talking about how populations resolve these conflicts. So what happens once populations are interacting? How do they resolve conflicts in their different ideas? So we based our models on equations from the field of genetics. So as a brief background on genetics, alleles are the variations of a gene. So for example, if a gene was for color, the allele could be for the color specifically white or black, and so on. And then we also talk a little bit about gene flow, which is the migration of alleles between populations. So as you can see in the picture, some alleles from one population are moving to another population. And so we modeled the interaction of the two groups based on this gene flow, where we assumed that the ideas would be moving between the groups similar to the way alleles are moved between populations. So again, ideas are alleles. So we had a few assumptions for this model. So firstly, groups arrive with one conflict resolution model. And we thought that this was a valid assumption because refugee groups have established different conflict resolution strategies due to their own traditions. So they likely already have one pre-established one. Our second assumption was that resolution techniques are all equally likely to be used. So this is the assumption that one resolution strategy is not necessarily more popular or more favorable than another. It's merely that people have traditionally decided to use certain conflict resolution strategies over another. Finally, we assume that if an individual had all three conflict resolution strategies, they will only use the one that is most dominant in the population. So this is similar to genetics where there's one dominant allele. So we figured that people would want to resolve conflict, and so they would use the strategy that was most likely to work, even if they knew that other strategies, as well. So in this model, we assume that alleles are ideas again. So as you can see, the different people have different alleles and different ideas. So P would represent, for example, negotiation, Q could represent arbitration, and so on. So inspired by these models, we represent these we represent an individual's preference for conflict resolution through these three properties. So if a new refugee only knows one approach, for example, arbitration, they would be represented by PPP. Similarly, if they knew all three approaches, they would be represented as PQR. So as these individuals interact and conflict resolution occurs, these ideas are transferred over to each other. And the ideas are randomly redistributed between the two individuals. So there would be 6 possibilities and 3 characteristics as chosen by chance and reassigned to each individual. And you can see that through our 6 choose 3 and through the GIF. So the rate of idea exchange is proportional to the interaction between the two groups. And then finally, we also wanted to model the rate of population movement. So if new refugees were to join the camp. So we represented this through the island continent model, which is a model normally used for representing gene flow over time. So this model represents allele frequency. And in this case, it represents the frequency of an idea within the population when a new population joins. So to define the terms, so the big Q represents the frequency of ideas in the migrating population, so the new refugees that are coming into this population. Q0 represents the original allelic frequency or idea frequency in the original population that they're joining. And then Q1 represents the new allelic frequency after the two groups combine. And M would represent the proportion of the population that is migrant. So this essentially represents the rate of migration.
So then what we do is we model this using a Python simulation to basically model this mating interactions and to see what is the change in allelic frequency over time. What we want to see is how do different types of parameters affect the allelic frequency over time. We see that when there's a high interaction rate, aka when the value of A is very high, there's much more fluctuation in the rate of allelic frequency, which means there's much more fluctuation in how the community handles conflict. For example, we see that R goes down a lot and then comes back up, whereas P fluctuations being the best and the second best. And then similarly, when there's lower interaction, kind of the frequencies don't really change as much, which means that the community, the best method of interaction can really change as much. Similarly, when there's a large amount of people already present and some more people come in, there's not as much, per se, like influence on the allelic frequency because the population is already large. Whereas when there's a small population, when more people come in, there's more of an effect, and so there's more fluctuation in the allelic frequency when the initial population is relatively small. And so basically our big ideas is that the conflict model presents and predicts idea exchange based on interactivity. And so depending on how the interaction parameter works, we can see allelic frequency, or in other words, the ideas change. And after time, the frequencies tend towards an equilibrium. Moreover, large populations make interaction difficult, or more, in other words, it makes changing the ideas more difficult just because the population is already large.
We then wanted to address some strengths and limitations of our model. So first of all, our model is adaptable to different values. So given more research, we would be able to adapt for many different situations. Going in that vein, our model also accounts for a lot of different factors such as interaction, migration, and changing traits over time. And so these make it more applicable to the real world situation. We also utilize an interaction model for conflict resolution, so we combine the two pieces of information. However, a limitation is that there are no concrete data or results since this is not a very well-studied area. And since our results are dependent on the data that would be collected, it is hard to determine whether the groups would integrate or separate, because this would be heavily dependent on group size and group composition. Additionally, resolution strategies are not necessarily used equally as we assumed. Some strategies may be more effective or more popular than others, and as a result, there could be some effects on our results. Finally, groups may have initial hostility that we did not account for. So in our model, we assumed that there was no hostility, but prior history could potentially affect the results.
For our future directions, we would like to address our previous limitations. One of our greatest limitations is data. This data is important because it influences interaction. And interaction is a great variable as high interaction makes it so that the populations tend to come together and have one prevailing method. Low interaction means groups stay apart. And as groups stay apart and don't interact with each other, there's no chance for cultural diffusion. Thus, the practices and traditions that each group came in with tend to stay with them, and the groups do not have one prevailing method overall.